Bernard, are you planning to share the live slides?
Yeah, yeah. For some reason, the PDF version is showing an old slide deck. So
You might have you. I seem to recall that sometimes you need to like reload your own session so that it knows.
oh,
I
so
think
like okay. Well, let me try that, and we'll see
okay.
if it works.
Mhm.
Okay, hold on.
Confirm that because I prove that almost every IETF and hot RFC. Because we always get things at the last minute.
No luck. Bernard, you still have no media, by the way, if you wanted to say anything.
This is the AVT Core Working Group Virtual Interim. Presumably, it's being recorded, so be aware of that. And I guess, Jonathan, you can walk us through the usual boilerplate.
Yes. Yeah, let's see. So yes, virtual interim meeting tips. I think most people here have used Medico before, but it's remember that you need to enable your own audio. Also, that can be quite slow sometimes. So, Becca, can you mute? I think I'm hearing echo from you. Or I can mute you. Yeah. So yeah, you'll need to please, please stay muted when you're not talking, and so forth. Note well, IETF has various policies, including IPR and participation policies and code of conduct and privacy policies. By participating, you agree to them. See your lawyer for more details. Not really well. Please, as mentioned, we are under the code of conduct and the anti-harassment policy. Please behave professionally, respectfully to all participants. And if you feel that, and you know that the things are not being handled properly, please talk to the chairs or the ombuds team. Next. Okay. This is the meeting. Here's the link. Notes. There's also a link to the note-taking tool in Medico, the one that looks like a pencil on a piece of paper or perhaps a square. I'll keep an eye on Zulip if anybody says anything. So far, no one has. And we do need a note taker. So at this point, we will stall to ask somebody to please take notes. Anybody wish to volunteer? Let's see.
Yeah, we really do need someone to take notes. Yeah, pointless.
Let's see. Yeah. So we need somebody who's not presenting. I'm not sure who's presenting for all the sessions, but let's see.
Stefan, are you willing to take notes?
kicked out of the session already twice in the first 5 minutes. I'm willing to take notes on a best effort basis, and it's not going to be a particularly good effort, I fear.
Okay. Well, maybe we'll need 2 people then.
Yeah. Let's see.
It is also fair to ask people to check the notes for what they said and what they heard as the answer. This really is kind of a working group responsibility as much as it is 1 or 2 people.
True. So yes, everybody please keep, open up the note-taking tool and keep an eye on it, but we need somebody to be the primary note taker still.
And I will be happy to do that with someone else.
Anybody want to be an assistant note taker dispenser? Presumably, obviously principally when he's not talking, but also just as backup.
Do something. We'll see how good it is.
All right.
Thank you.
Sounds good. Thank you.
Thank you.
Okay. Here's our agenda. I'm not going to go over it in detail, but if anybody has any comments or requests to change it, let us know. Shouldn't take too long. All right. Okay, we've got various things published. I don't remember which of these are before the previous the IETF, but we are getting stuff done, so that's good. Let's see. In the RC editor queue, we've got VP9 and 7983 BIS, which is the quick multiplexing. VP9 is still waiting on frame marking indirectly, as I recall. AD follow-up on skip, which we have some proposed changes to be discussed today, and AD follow-up on frame marking with some proposed changes to be discussed today. Okay, we've adopted RTP over quick, EVC, green metadata, and V3C. All of which I think we're all discussing most of this today. Okay, next one. And next up is Skip. So who's presenting for that? Dan, great.
Dan, I'm presenting for that. Okay, let's go ahead here. I guess we published draft version 05 back on March 29th. Again, we'll read the whole list of things that we did change because we talked about this last at the meeting. Again, trying to refocus things on more from a network perspective rather than from a payload perspective, because again, we're trying to emphasize that Skip is an opaque payload and trying to define it at any particular point in time in the RPT stream is really difficult. And again, asking that network devices don't attempt to try to do packet filters on it, just because, again, it's hard to quantify specifically what Skip looks like, not only because of different messages, but because of it being encrypted, that it, again, makes it a very difficult payload to try to quantify at any point in time and try to produce a reliable packet filter, if you will. So basically, we just changed to say don't do it. So I guess other than that, I guess final slide is, I guess, again, we trying to figure out how to move forward. Again, I've contacted several of the reviewers from the ICSG and asked for their reviews, but I've heard absolutely nothing back from any of them for the last 2 months. I guess
Yeah, I've also sent mail, and I asked the area director, our area director, Murray, to send mail. He sent mail. He didn't get a response.
right. Yeah, so I guess we're sort of stuck at this point trying to figure out, well, what, how do we move things forward? I guess you said in a slide you have a couple of things that you may want to change, and we'll certainly be willing to listen to that and see what those changes are.
Yeah, I mean, I don't want to try to interpret somebody who's silent. as to what they want, but we could.
Okay.
But I did, in the deck, I did include the comments, the discussed comments that we're trying to address. So, I mean, here's, it's Roman and darker. So,
Right, and like I said, we've addressed those as much as we can. I mean, those are been there for 5 months now, so I mean, we've tried to address those as much as we can to put that in there. So
I think in particular, so let's talk about Roman's comment, the section 4 comment. I think the new draft does say the details are entirely opaque, right?
yes,
So we have been explicit in saying that.
right.
I guess maybe, well, there's the pre encryption messages, which aren't opaque, but after that it is. I don't know what you could say more other than copying text out of the skip document or something.
Right. Well, I maybe tried to illustrate that in the figure that we added,
Right.
saying that there
I mean,
are some clear messages and some encrypted messages. So
yeah. I mean, what I'm wondering, I mean, it's kind of these reviews were conducted without access to the skip documents, right? So they're saying they want something from the skip documents, but they haven't looked at the skip documents to actually be able to express what they're asking for.
Right.
So that's kind of a difficult position to even talk about, right? Because, I've read the skip documents. I think they're useful. I don't think they're required to implement this document, but my knowledge of that is based on reading the skip documents as opposed to not reading them.
Right.
So it's kind of a weird situation where if I hadn't read the skip documents, I might not know that I don't need the skip documents, if that makes any sense.
Right. And I mean, we're more than willing to provide them to them if they want to look at
Yeah,
it.
but the thing is, they haven't asked for them. I mean, we'd happily, I'm sure you'd provide them if they asked, but
Correct.
I'm just trying to understand how we get out of this situation. If they would ask and look at them, they then understand they don't need them. But you have to, it's like, I think I need something. Okay, we'll give it to you. I don't want it. I don't know. I don't know what to say about that.
Right. Right. Yeah. I mean, it's the fact that again that we've had radio silence the last 2 months is kind of disturbing.
Even
why has no one even bothered to respond to, ask them to re-review and post another discuss or something, but we haven't heard anything. So
right.
I don't know what's going on there.
All mail goes into the bid bucket.
Yeah.
So I don't know. Well, I understand why that happened with Francesca. She was legitimately on leave, but you addressed her comment. So that one I understand. These other ones I do not understand because those people I see email from them, just not to us.
Right. And there were others that were listed on that list, but they didn't have any contact information, at least what was on the, if you go to the ballots, other members of the review board, but
right.
they didn't have any contact information.
There's section 6 about RFC 7202. It just says that 7202 basically says there's different security solutions in the RTP ecosystem. He's saying he's not clear how this applies to skip.
Yeah, I mean, I was trying to understand that because I guess his point was basically saying that, well, because it's an encrypted stream, then you don't have to worry about any security. I mean, that was sort of my impression of what he was referring to in that section. That, because that's basically that 7202 is kind of boilerplate text saying, well, if this is how you address security concerns and, in certain payloads or whatever, which go ahead.
Yeah. So so he seems to be asking for the security properties, which I think you have somewhere in the document, right? Basically, I mean, I'm not sure what he means by security properties, but the services are indicated, or certainly they could be, basically authentication and encryption. Yeah, it's section 2 says end-to-end security application layer, authentication of user identity, and ability to apply different security levels. So
right.
I guess you could put that text into the security consideration section. It's already there, but you could put it somewhere else.
Right. Yeah, I mean, we could do that if you want, whatever, I guess whatever, makes them happy. Again, because they said, I mean, there's some clear and there's some encrypted traffic. So I guess you could sort of
Right. I mean,
try to make the argument that while whatever generic security concerns there are for any RTP stream still apply for that case, I guess.
Right. Yeah, I mean,
but at the same time, in parallel, it's also encrypted, and then others say it's also encrypted, so maybe it doesn't apply for that. I mean, you make the argument both ways, I guess, on that. But
I mean, but that's true of all key management traffic, right? It's sent in the clear until you push down the keys, so that's not news. But I mean, the way you can clarify that is with the state machine, but it'll look like, I mean, the state machine will look exactly like it, pretty much what it does in IPsec or other encryption protocols, right? The stuff is in the clear, but I don't know what the point of that is because it's inside of Skip. Okay, so this is Sarkler's discuss, and he's asking about the RTP profile. But the answer to that is it could be any profile, right? Depending on what the
depending on what the state of this,
right.
The Skip, the state machine is basically, it could be, like I said, anything. That's why we've avoided trying to do that, because it's, depending on what messages are being sent, they're different sizes and some are clear.
Yeah, I mean, as an example, you could negotiate SRTP or not. Right? That's just, you don't, I mean,
well, I suppose, I guess that's really out of band of Skip. I mean, I suppose you could
right, exactly.
run both or whatever. So it's kind of,
you could.
Doesn't apply to Skip,
I guess you could say that that's a point of confusion. It's like, yes, you could do SRTP or you could not do SRTP, but that's not related to the payload per se. I mean, we don't say that in every RTP profile spec. You could do SRTP or you could not, but I guess we could say it if that helps them. So he does have confusion about the term variable, because he's wondering if it means variable bitrate, which it doesn't.
No, it's the sense that this output stream is variable size packets. It's not like a 711
right, so
codec
he's confused about that. He
like
thinks it means variable bitrate. So that's something we could fix, I guess.
Right, and we changed that. We changed that wording in the last revision, so that has been addressed already. So
what bitrate is specified in the SDP? I guess you could put the B parameter in if you wanted to, right? Max bitrate or whatever.
Yeah, well, I think that's relating to the previous comment. I think that's what he was relating to the confusion about, variable bitrate, and so I didn't see that as being applying the need to put a B parameter. If you wanted to put it, you can. But that was not, I think that was not the meaning of what that was.
Right. Jitter buffer. The jitter buffer may be implemented in endpoint devices only. All right. So he doesn't like the may. Yeah. Well, you're not saying that it's optional to have a jitter buffer.
Well, I'm saying it's not required to have, that's implementation specific. If a device wants to do it, do it or not do it. I mean, I suppose it's not required in 3550.
Right. Well, but
that I'm aware of, top of my head, I don't think it is. But
well, and that's also because Skip has a jitter buffer, right?
Spencer?
No.
Let's hear your hand.
Thank you. My working group is working through a discuss about a may that probably should have been might.
Right.
It's not a BCP 14 may, but basically the conversation we're having on our discuss is that this is not a BCP 14 use of the word may, and saying that it could be or might be.
Right.
It takes that off the table.
Yeah, I think this use of may be gratuitous.
It often is. I mean, this is what we do, right?
Yeah. So that's a suggestion, Dan, is maybe it could be or something like that. Because they're freaking out because you're saying jitter buffer structure.
Okay, right. Yeah, we could change it to could be.
But
Yeah.
so how about this? Why don't we try to focus on Sarkar's discuss, because that one seems eminently addressable.
Mhm.
So can we make that the goal, and we'll all send emails to him? I'm just trying to eat this elephant one bite at a time.
Right, right. Yeah, I'll have to go back. We made some. Yeah, I guess we didn't change the jitter buffer wording on that, but I can go back and look at that to see.
So let's do this. Let's try to have a proposed set of changes for the Sarkar discuss, and then send it to him and see if he thinks they're okay, or comes back and says, I want this other thing in addition.
Okay. Yeah, we can do that.
Okay. Well, thank you. And then we'll see if we can whittle this down.
Right. Okay.
Says he has well, he's asking for a link to the spec, and he said he had a hard time finding documentation. Well, were we not clear that you had to ask for it? I don't know.
Right. Right.
Anyway.
Yeah, I mean, you can find an older version of the spec online, and you can Google it and you can find it.
Yeah,
That's
which I did.
it's like 10 years old. So.
Right.
So.
Okay. Thank you.
All right.
All right.
Thanks,
So this next one is about discussion of the discusses on frame marking. I guess Mo isn't here. We can,
Bernard, I actually
Mo's
have my
here.
hand up.
Oh, sorry.
Mo's here. Okay.
Previous.
Okay, yeah. Go ahead, Spencer, on the previous.
I was just going to say that my encouragement to the authors chair and working group would be that as long as we're making changes that do improve the document, that making changes that improve the document is a fine thing to do. But if we get to the point where other additional changes are not going to improve the document, and we're just negotiating with ourselves.
Right. That's where we are
that,
now.
Well, but that's a conversation that the chair is going to have with the AD about doing things like, and just for an example, putting this document on a telechat agenda as a returning item.
Okay, that's a good point.
As a kind of as a it's easy for area directors to forget about one discuss among many.
Right.
It was for me.
Okay, so that's a good point, Spencer. We can try to get it put on as a returning document, and that will almost certainly generate new feedback. Okay, thank you. So I guess this segment here is to understand what we need to do to address Paul Wooter's discuss on frame marking. And just reading this discuss, it says the document has no privacy considerations section, but as far as I know, I mean, we wrote the IAB statement on privacy. There's no requirement to have one. But basically what he's asking about is, I guess, encryption of header extensions. So, what do you think? How can we resolve this? Do we just put in a reference to cryptex or something in section 4?
seeing as how we've now published cryptdex, I have no objection to that. Mo, you don't have to raise your hand, Mo. You're the first speaker here.
Yeah, the security considerations can just be augmented to add some points about the privacy considerations. I'm not sure if it really changes anything. I mean, I don't think it really changes the security posture of how this is used. The whole point of this was that it would be understandable by the middle boxes. Frame marking doesn't make sense for end to end. It only makes sense for deployments with middle boxes.
Right, right.
So we can spell that out in a privacy considerations that that this is not this is intentionally being revealed to a middle box, and you'd have to be okay with that to implement it.
Yeah, I mean, I think the point is that standard SRTB header extensions expose on the wire, and I think if you could use cryptdex or potentially the whatever the older RFC number was, but probably cryptdex is better. Then it's only exposed to the middle box itself, not on the wire, which fair.
Well, but
So maybe a recommendation to use, you might want to consider using cryptdex if you feel these things are privacy sensitive.
well, he's also
So,
saying the other party's saying don't send these bits all the time. That seems, I don't know if that makes any sense.
Yeah, no, I think saying keep them secure rather than not sending them all the time is probably a better solution to that.
well, that's what I was kind of alluding to, is that in an end-to-end case where you don't have middle boxes, there's not that much value in frame marking. There's a little bit of value because it adds a little bit more determinism in when you have losses, but it's not. I don't think someone would implement it just for that extra determinism. It's really only for conferencing topologies with middle boxes, and so it really wouldn't be negotiated. We can add some text to say, this is intended to be negotiated for topologies with middle boxes, and if you're not using that topology, then for privacy considerations, it may be better to not negotiate this.
Sure. Okay, that all sounds reasonable, and hopefully we'll address to discuss. Thank you, Mo. And by the way, yeah.
So do you want text in a version 15 that says that, and then present that for the discuss, or you want to just have a proposal first to Paul?
Well, if you can actually get him to respond to you, a proposal first might be reasonable. If that doesn't happen, I wouldn't wait. Hold your breath.
Okay. We'll try one round of email. If it doesn't work, we'll just do the draft update and follow the process.
Okay.
Spencer, did you have something to say?
Yeah, my apologies. I'm still trying to catch up with the minutes on the skip document, so I did not take any notes at all on this document. And if somebody could take notes while I'm, for like 2 or 3 minutes, and I'll say that I'm back in the chat, that would really be helpful.
Maybe we could help you out by Mo. Can you summarize what you think the next step is?
That would be a fine thing to do, and I'm not finished yet, so I'm trying to get. I was trying to raise awareness of this, so I wouldn't be just sitting trying to flag down the meeting for the whole time and not taking notes.
Okay.
Yeah. So Spencer, my summary would be that we will add privacy considerations in the security considerations section, and mention that this is intended for topologies with middle boxes, and it's not recommended to negotiate it in other topologies to preserve privacy.
Yeah, we could also mention cryptdex as,
Yeah, basically. Yeah, which you might want to use if you feel there's issues of exposure.
Yes.
You got that,
Did
Spencer?
you get that? Or do you want Mo to actually just type it himself into the note take?
Yeah, Mo, you can type it in.
That
I
would
got
be superior. Usually I have two screens, and I'm in a hotel. So
I got it. I wrote this down. I
Oh,
wrote
good,
down
good.
what Edward was
perfectly.
saying.
Thank you.
Uh,
Thank you, Stefan.
if you could stick that in the notes, that would be awesome.
Okay, excellent. All right. So now we're at the B3C payload format. Lori?
All right. I hope everyone can hear me all right.
Yes.
So thanks for accommodating this to your agenda today. I wanted to just make you aware that the version with the changes presented in the last online meeting or like in-person meeting is now available. And you can have a look at that. And after that, or shortly after making this available, a couple of new issues were created for the draft. One proposing to change the previously hex coded fields to base 64 coded fields, like in DVC RTP payload format. I suppose this makes sense, but I also looked at HEVC RTP payload format specification, and there it seems that there's a mix of base 16 and base 64 coded fields. Personally, I think it might be better to just keep with one coding rather than mix them together in the same specification. So I was thinking that we should just move to this base 64 coded fields. Another issue that was added was to remove comments from the example SDP fields and add them as text instead to kind of maintain the syntax correctness for the SDP examples. And yeah, those are the two new things that I'm trying to or planning to address for the next meeting. And as always, new more ideas and suggestions are always welcome. And you can file these issues under the link here. And yeah, that's it. No requests, just an update of what's happening.
Okay. If there are no
How
questions,
far do you think you are from being? How far do you think you are from being done and ready for working with last call?
I mean, these are minor changes, right? So I think it should be fairly straightforward from this point on.
Yeah, if you think you're
should be ready.
your feature complete and have no open issues, then presumably we should move to working with last call.
That was the idea.
All right. Bernard and I will figure out who's going to run that one.
okay.
Okay. Green metadata, who's presenting for this one?
Guess there's not much more new content here.
Hi.
Yeah.
Okay. Can you hear me now?
Yeah.
Yeah. Okay. Thank you. Yeah. So Yong is not present today in today's meeting, so I'm presenting on behalf of him. This is Srinivas. So we updated the title of the draft as because these are the RTCP messages for temporal spatial resolution. This basically is not presenting all the messages that are part of the green metadata. So it's only presenting the temporal and spatial resolution requests. So as per the request, we changed the title to RTCP messages for temporal and spatial resolutions. And also we received a comment saying that the constraint should be added in the class for 4.1.2. So the temporal and spatial resolutions in the TSRR message shall not be more than the resolutions that are negotiated in the SDP via the SDP. So the constraint has been added in the IETF draft. So these are the changes that we made it and we uploaded the revision in April. And we haven't received any other feedback. So as usual, we are open to receive the feedback here on AVT Core Reflector.
Just out of curiosity, what happens if the temporal and spatial resolutions in the TSRR are greater than what was in SDP?
I think we should receive error messages. So it's not accepted. So it should be basically maximum of what is it's negotiated during the SDP. Yeah, the responder should not accept for anything more than that. But anyhow, in the RTCP, the UE actually requesting UE shall request only less than the resolutions that are negotiated during the SDP negotiation.
Yeah, it's just useful to say what the receiver ought to do if it gets something that doesn't make sense.
Yeah. Okay. Sure. I can update like the receiver behavior as well. Sure.
Stefan?
I would, you know, I wouldn't put sender-based constraints there and expect them to be obeyed. I would just say what the receiver is doing. Yeah, I would write rather something like it doesn't make sense to send TSSR messages with resolutions higher than what RTCP what SDP has negotiated, and if anything like that is received, the receiver shall ignore it.
Or,
in other words,
or at least, or
that's I think what
never
we usually
respond
do,
with
right?
anything higher than, basically it's a double constraint. You'll never send anything higher than the SDP constraints, as well as the.
Yeah,
but
I think maybe we can add that. Yeah.
Yeah.
You know, the burden should be on the receiver to react on, in the spirit of that we don't want to, you know, we want to be tolerant against stupid senders, right? We don't want to have an application crash because some idiot doesn't read this line, right, or doesn't read this shell statement. And we don't want to get into non-compliance arguments either. So just make it receiver centric. Then it's clear who is at fault if something goes wrong. Thank you.
Sure, thank you. Yeah, we can update that the receiver of the RTCP message shall ignore if it is more than the negotiated resolution, spatial or temporal resolutions. Definitely, yeah. We can include that.
I mean, I would actually, I mean, ignore is sort of a little tricky because I think you still want to send the TSRN with the, you know, basically just never send anything higher, never send the TSRN higher than the, you know, or the media higher than the SDP. But if you just ignore, that might imply don't respond to the TSRN, which means somebody would keep representing the TSRR forever, which is a bad outcome too. So I would say basically.
Yeah, so the request will be ignored, but there will be a TSRN message with the actual with what has been actually been used by the sender. So that spatial and temporal resolution will be included in the TSRN message. So TSRN message will still be flowing, but the request will not be accepted or
acted upon. Yeah.
Exactly.
That makes sense.
Sure, we can. Yeah.
Okay. Spencer, did you get that for the notes?
I think so. Again, it would be great if somebody is looking at what I'm typing. There are 6 people in the Meet Echo document, and I'm not seeing things coming along, but anyone coming along behind me and changing anything. I don't know what that means, of course.
Yeah, so Srinivas, have a look at what is in the minutes, and if you clear enough.
Sure,
Yeah.
I can check the notes. Yeah, I can check the notes and I can update it. Yeah, thank you.
Because soon Spencer will be, I guess, talking. So, or is it Mathis?
Hi, yeah, it's me.
This is Spencer. I really need to be paying attention to what my co-author is saying and not just trying to type the words down. Can somebody
Okay.
take notes for this?
James says he can cover briefly. Thank you.
I'm taking best effort basis.
And
Okay.
you're offline. You're taking notes offline, not in the head doc, right?
Yeah, please.
Okay.
Multiple screens here and multiple sessions ongoing, not only AVT.
Okay.
All right.
Thank you all.
All right, so we have a couple of updates since we last met in Yokohama. I want to start with a couple of things we merged into the document since then, and then later I have a couple of slides on issues we're currently working on or we're planning to work on next. Next slide, please. As first, RTCP analysis. We already mentioned this one in Yokohama. We basically added a large table of a lot of different RTCP packet types and subtypes, and for each of them we explained if there is equivalent information that we can use from Quick. And for a lot of them, that means that we only have a entry in our table which says there's nothing to be done about this, but we still included that because we wanted to make sure that we document what we considered in this document. Then in the same PRs here, we also, Bernard, did you want to say something or? Okay, so in the same PRs here, we also swapped the sections we had on RTCP before with the one we have now, but this is the sole RTCP analysis is still work in progress because we still have a couple of open issues related to this. One is that was mentioned, I think, in the last meeting we had, that we don't really consider that there are differences for how we can replace certain RTCP fields in different topologies, because for one-to-one connections that may be different than from topologies where we have multiple hops and quick connections between different nodes in the topology. And then the information we get from Quick is of course not the same as you would get it from RTCP, so we will add some considerations for that. Then the analysis does not yet include green metadata. I guess depending on how fast that progresses, we can add a note for that. I'm not sure how much we can say about this, but it would probably make sense to at least add a note, as we did for many other RTCP fields, that we considered this. Then there's, at the moment, there are a few sections which are duplicated because we have fields in our new tables, and we also had some text about that before. So we added, or we should add references to that and remove some of the duplicated text. Yeah, I don't know what the last point was on that slide, but anyway, topologies is similar as for RTCP analysis. We added a large table for the topologies from RFC 7667. And for all of them, we explained how well it works with RTP over Quick, if there's anything to consider about that. And then there's, again, the related issue, which I already mentioned for RTCP, that we don't have good considerations for multi-hop topologies with RTCP. So we may need to do some changes to the topology section here too. All right, next slide, please. Then we merged a pull request about congestion control terms and definitions. We added terms and definitions for these fields here, like for delay-based and low-latency congestion control algorithms, for loss-based congestion control algorithm. And then we have explanations for what we mean when we say quick congestion controller or RTP congestion controller, because we thought that makes it much easier to understand what we say about congestion control in the sections later, when we have clear definitions of these terms. And And we have a few more about congestion control on the next slides. Yeah, we explained why we don't make any BCP recommendations for congestion control algorithm. And the reason is basically that the choice is often dependent on application or codec specific things. And we have a couple of references to different algorithms, but they are all informative. And the references are mostly to the RMCAD algorithms, which are all experimental. And then we have a reference to the GCC draft, which is currently an expired draft from a couple of years back. And so we think that it makes more sense to have these as informative references rather than as BCP recommendations. Next slide, please. I think this was the biggest change we have about congestion control in the recent updates. We rearranged the section a little bit and added some parts from the introduction to that section to more specific subsections. And we added a new subject section, which talks more clearly about resolving interactions between quick and application layer congestion control, and explains issues that can appear when we have congestion control at different layers. This talks about what happens if we are application limited, or what happens if we have different kinds of congestion control in the quick layer that react differently and may have an impact on what happens on the RTP layer. There are still a couple of open issues for congestion control. The first two are about how to handle congestion control for shared connections. One is for shared connections on a single 5-tuple. I'm not sure how much we can say about that, but probably there should be some consideration that there could be impacts on the different connections depending on what congestion control they use. And the second one is what congestion control impacts there are if we have media and non-real-time streams sharing one single connection. And then we still have an issue about whether real-time congestion control algorithms are suitable for quick stacks themselves. Like if we would implement any of these directly in the quick stack, I think there may be some need to do some research on that. So we have this as an open issue and we'll work on that in the future. Next slide, please. Okay, stop sending. We already talked about stop sending in the last two meetings, I think. And in Yokohama, I already explained that the problem with that is we need to somehow define how to handle stop sending on sender side. What happens if the sender receives stop sending from the RTP receiver, because the receiver might send that at any time because it's in quick. So the sender which receives stop sending doesn't really know which stream does, or which media frame on that stream does the receiver actually want to cancel. And the receiver might not know what is actually following on that same quick stream. So that could lead to a situation where the receiver accidentally cancels more media frames than intended. Next slide, please. So now we added in pull request 88 that we paraphrase RFC 9000 here from Quick, which says basically that a quick sender that receives stop sending must send a reset stream afterwards, and it should not retransmit any data that was declared lost. And now we add to that an RTP sender, which sends some media stream on quick streams, should or must continue sending the media stream, but it must do that on a new quick stream, or generally will open more new quick streams anyway. And that the RTP sender must not retransmit media frames that have already been transmitted on the previous quick stream that received the stop sending frame on new quick streams. That was something we discussed in Yokohama, I think, because if the receiver says, hey, stop sending me that frame because it's too late, then the sender should of course not start resending the same frames on new quick streams.
Bernard?
Bernard.
Yeah, I just have a question about I think there's an issue here about, like you said, it's not clear what the receiver is trying to do when it stop sending. So I'm wondering if you think the semantics are clear for everything. I think we basically said we didn't want to interpret application layer semantics based on the quick message. But I guess the question is why. The question is why you would send a stop sending. What do you think the purpose of it is? And does that make sense? Is it just to try to cancel a frame?
Yeah, so I think what we said in Yokohama is that we actually would like to drop this as a feature which we advertise in our document, because exactly for that reason. But the feedback we got in Yokohama was, as I understood it, is that we still need to say something about stop sending, because it is in quick and any quick implementation may send that. So we need to add some text that says how our sender should handle this situation.
Because for example,
could I just add a couple things as we're talking? This is actually a PR I wrote, so that's why I'm asking. or a lot of feedback on it. Anyway, this one, so basically, I think we for some value of we have been a little bit confused about how, about what stop sending would mean, because let's say in HTTP 3, if you say stop sending, I really have lost interest.
Right.
But in RTP, that's not necessarily true, because what I've lost interest in is not the RTP stream. I've lost interest in getting frames that are too old for me to do anything with.
Right.
So and I'm not trying to say that stop sending is the right way to clear the queue, basically. So that gives the RTP sender a opportunity to start with the newest information they've got. So basically, you get one big blip instead of a bunch of small blips every time you get another RTP frame that's just a little bit too old. So, like I say, I'm not. It may be that we're conflating two different things in this conversation, and I believe Mattis has a fascinating third slide on this immediately following. But I think that's one of the things that's going on.
Because in conventional RTP, right, you have the negotiation of RTX time, where basically the sender knows if it takes more than this, don't bother. You allow through basically reset for the sender to be a little bit more sophisticated, maybe vary the reset times depending on what kind of packet it's sending or frame it's sending. So you have that on the sender side. And then I guess, I mean, you guys can think it over, but the question is, is there a role for stop sending? And if so, what it is as well? I mean, I think the things you have.
I'm agreeing with what you're saying, Bernard, and I think I would maybe even just add that there's a role for an RTP receiver explaining to the RTP sender that they need to change the leading edge of what's being transmitted. And if stop sending turns out to be a way to do that, fine. If it doesn't turn out to be a way to do that, we still have to explain what stop sending means.
Right, right. Yeah, I think the first line here, which is essentially saying that stop sending is a way of suggesting to the sender to send reset stream. So it's kind of a receiver initiated reset stream, I guess.
Yeah, and I mean that's RFC 9000 kind of language. I
Right.
paraphrase, so I may not be perfect, but it's, it seemed kind of blunt about that. It basically uses words like the reset, the stop sending triggers a reset stream.
Right. Yeah. Okay, thank you.
Jörg is still in the queue. Do you want to add something, or?
So can you hear me? Yep. I just wanted to offer two more additions to what Spencer said. I see, Bernard, I see your point about the RTP level operations, but we shouldn't forget that we have, if we are talking about streams, we have an undetermined amount of data buffered inside QUIC that the RTP sender doesn't really have control over. So you will not know when you're no longer in control of retransmissions. And this is a legitimate way to cancel any outstanding efforts. We could, of course, do this similar semantics of signaling a layer above, but one of the things that we try to do also is to reduce the amount of extra RTP and RTP-CP signaling also in other places, so that we can make of the good use of the features that are available. It stands to be validated that this is truly the complete and comprehensive semantics exactly of what we want. But I believe there is a very legitimate reason for having this, or this kind of mechanism at least, in mind. Hope that helps.
This is Spencer just saying that Spencer agrees that what Jörg said was helpful. Thank you.
Thank you.
Yeah, I think I agree. Obviously, QUIC says stop sending means reset stream, but the question is, if you're sending a multiple frames per stream semantic, what goes on your next stream? If you're doing a single frame per stream semantic, I think it's pretty straightforward. Stop that frame, send another frame. But if you're doing multiple frames per stream semantic, where do you resume? And that's the thing that's unclear.
Okay, can we go back one slide? So what we have in the draft now is that a sender that receives stop sending and knows what media frames it sent on that stream should restart sending new media frames on new streams, only starting with that media frame that was not transmitted on the stop sending stream before. Because stop sending does not have an offset, and so we can't really have any mechanism that tells the sender, I got until here and please start from that frame with new QUIC streams. So we currently in the document just say I think best thing the sender can do is to start with new media frames that have not been transmitted on the stream before. Does that make sense?
Yeah, I mean, I think it's obviously you don't know what the receiver had received at the time it stopped sending, and it's not clear. It's not clear that a receiver can usefully do this for a multiple RTP frames per stream.
Yes, it is. I think it is possible that the receiver accidentally cancels more media frames than it intended.
Yeah, so maybe there needs to be language saying, if the sender is doing multiple frames per stream, you may not want to do this because you don't know what you're going to get.
Yeah, we have that in the draft, and
okay, good.
Yeah, we have a note that says it is possible that there's data on that stream following that the receiver doesn't know about, and it may accidentally be canceled by sending, stop sending. So you might want to use other mechanisms for that.
Okay.
Or, Jörg, again?
Yeah, and on the next slide, one of the things we are kind of getting at there is how much is basically, so how does the RTP receiver tell the RTP sender what to do? And if the only tool is stop sending, we may not be very happy with that for multiple frames per stream. Then if that really turns into a requirement, it might be good to advance to the next slide, because that's actually what I'm talking about. But basically, this is why we have the line down there about using streams, datagrams, and per RTP frame streams with, and even the multiple RTP frame streams, but being willing to close a stream and reopen a new stream in order to fast forward to something useful. But all this is about, we know what the quick tool is, and tools we have available are, and we need to think about whether whether we can use those tools to do the thing we need to do, or whether we need some other tool. I'm not necessarily happy about that, but we are talking about the issue. I think the conversation we're having about the issues is correct and helpful. So if that's true, then we really need to look more carefully at things. Thank you.
I wanted to come back to what Jonathan said, and maybe also add a bit onto what Spencer just said. Effectively saying that we shouldn't be trying to over-specify at a fairly low layer the semantics an application might try to implement. We do have a need for a receiver to signal that whatever is coming on a given stream is so late that it won't be of use anymore. That is a very straightforward interpretation. The reaction to this, whether you're using multiple frames per stream in the first place, or whether you're using just one frame per stream, or if you're using multiple frames per stream, what your packing strategy then might be heavily dependent on the application context. It would appear to me premature to try and embrace all these potential thoughts that an application might have at that level when we are effectively trying to tell this stream is too late. If, as Spencer alluded to, as the tools we will require for some specific application uses, additional signaling bits that tell us further details on how a sender should react, then we may well specify those later on. But it appears too hypothetical to me to try and cover all potential use cases, including their semantics at this point. That ain't going to get us anywhere, because we will surely miss something. So therefore, I'd like to stay a bit closer to the actual semantics of what this means to a particular stream. And the remedy action may be obvious for some senders. It may be less obvious for other senders. It may be a part of negotiation that applications have performed before, or of their implicit understanding. So maybe I just want to try to prevent us from interpreting too much semantics into this more transport-related mechanism here.
Right.
All right, then just adding one more note to the stop sending part, we have one more open issue for discussing exactly this: how are streams being used and what can we assume about that? And then we have one open pull request which still fixes some of the wording we have from what we changed before. And yeah, then let's continue with max streams. We also talked about that in Yokohama, and the problem for max streams is that receiver needs to give a sender enough quick stream credits to open enough streams so that it can send all the media. And the receiver needs to do that fast enough. And we don't really have a very concrete way to tell in the draft how that should be done, because it's depending on a lot of factors. So we now added an example calculation for one scenario, like it was suggested in Yokohama. And then we also added a note that some signaling may be required here, because if the receiver doesn't know what the sender is going to send, then it's going to be hard to set max streams correctly. So depending on what the scenario is, there may be some signaling that helps tell the receiver they're going to be so many new streams or so many media streams, so you have to open so many quicks or allow so many quick streams. Yeah, that was merged in this pull request too. Next slide, please. Yeah, this one is easy. We added an acronym work for into the draft. We decided to use ROQ here because it matches what also DNS and Media over Quick do. So that's consistent with what's in their use.
Is that pronounced rock?
Yeah, you're welcome to pronounce that rock. Next slide, please. Okay, so then we have a couple of one open pull request currently, I think, in addition to the one for stop sending, which I already mentioned. About error codes, this is still kind of work in progress. There's an issue 76 which asks about error codes, which makes sense because we need to define error codes for different things that can happen in Quick. And then there's issue 13, which has been open for quite a while, which also could be solved by adding error codes or using error codes appropriately. I have 2 slides of error codes which we came up with so far, but we of course welcome comments on whether these make sense and whether we missed something. I took some of these from other documents like HTTP 3 and DNS over Quick. I'll just quickly go through them. So no error could be used, for example, to close a connection or a stream if there's just no other reason, just closing the connection. Then I think general protocol error could be used for when there's no more specific one. That seems to be something that makes sense because it's also in the other documents. Internal error is, I think, also clear. Stream creation error, we specify in the section about quick streams that we only use unidirectional streams. So if a sender tries to open a bidirectional stream to send RTP, for example, that could be used as an error code. Next slide, please. Then we have packet error for invalid packet payload formats. If the payload format is not compliant with what we specify in the draft for how RTP packets are encapsulated, or also for non-RTP things that are sent, and for example, the flow ID or the whole thing is not formatted correctly. Then we have frame canceled, which would be what we just talked about, stop sending. Then unknown flow ID. In theory, I think we could allow receivers to accept any flow ID if they know what to do with it. But if the receiver does not accept the flow ID or it was not negotiated for an RTP stream, then we could use this as an error code here. And then signaling error is for a situation which was described in this issue 13, where, for example, if we do signaling outside of QUIC, which says that we want to use QUIC RTP over QUIC datagrams, but then we open a QUIC connection which does not support datagrams, then we need something to tell there's an error. All right, yeah, thanks. Then we have a couple of more open issues, which we have not started working on yet, but plan to do after we finish the stop sending PR and the error codes PR. We have number 50, which is ICE interaction. We haven't done anything about that so far, but I think there will be a later slot in this meeting, which may help. I don't know, but we'll see. Then we have issue 77, which is about extending motivation for adoption of RTP over QUIC, which adds a few more nodes to, I think, protocol overview or to the introduction for why one would want to use RTP over QUIC. Then we have an issue about reduced MTU sizes versus extra packet considerations, because if we want to add QUIC eggs in the same packets as QUIC datagram frames, then that would reduce the MTU even further. And we might want to add a node for that. Then if we have small RTP packets, they could be batched in single QUIC packets. Maybe helpful to have a note about that too. Yeah, then we have a couple of...
That would have latency constraints.
Sorry?
The batching would also potentially have latency issues, right?
Yeah.
So you mentioned that there. Okay.
Yeah. Then we have a couple of quick extensions which we already mentioned in the draft. We always said that none of them is required, but it would be helpful to have a list of extensions that are mentioned somewhere else in the draft and that are helpful for different things. And then the using streams, datagrams, and per RTP frame streams with work is what we also just talked about in stop sending. Then the last two issues down here are things that we are not sure yet if there's something we can do about this in this document. We have issue labels on these currently, next doc, enhancement, and not just RTP. So we are not sure if we are going to do something about these. For example, multipath and multicast are still in development, and maybe that's something that should be solved in a future document, but we still have them open and on our radar, but currently no plan to do anything on these. And I think that was all from my side today. Any further questions?
Okay, thank you. So the next topic is an HEVC profile for WebRTC. Basically, the need for this came about because browsers are actually adding support for HEVC. So in Web Codecs API, decode is supported today for hardware only. And typically, the support is for main profile level 3.1. I haven't gotten a look at all the chipsets, so I don't know what other things are supported, but at least so level 3.1 seems very common. Encode is a work in progress that will also be hardware only, and there's a tracker bug where you can see what progress they're making. There's a registration page in Web Codecs that tells you what encode options there are for HEVC. Because the support is hardware only, we've only looked at adding stuff that will be very commonly supported on different hardware chipsets. Some of the more advanced things like screen coding, at least so far, don't seem to be supported, so we haven't added it yet. But if you have suggestions, you can file an issue about the registration. So now that the encode decode APIs are getting HEVC support, the next question has been, what about WebRTC? So there's a tracker bug that tracks the progress on supporting that. It will also be hardware only. work is proceeding on implementing RFC 7798 packetization and depacketization. But one question that came up is, what is the SDP that's going to be supported as part of that? So that's they would need that in order to finally ship this and get HTTP supported in WebRTC. There's no guidance. The WebRTC video document is RFC 7742, doesn't talk about HEVC, only about ABC. So there's a little bit of a hole there that we're trying to fill in with this document. So it's basically, in what we're trying to do, we generally use the approach taken by RFC 7742. There's not a lot of guidance here, but basically it says you got to support the RFC 7798 format. And it requires support for level 3.1 and suggests support for main profile level 4. And it requires support for receiving, and I guess may support ability to send. So the decoder is required, but the encoder is, I guess you could say, optional, although presumably you'd get both once the encode support is in there. And then the question is, what STB parameters need to be supported in WebRTC? And obvious one is the level ID, and also some of the same parameters that are in the AVC section under 7742, such as max FPS, max BR, etc. This kind of stuff. And then for the VPS, SPS, and PPS, the same approach is taken as 7742, which basically says that WebRTC implementations will signal the information in band and won't put it in the SDP. And that seems to be working okay so far for AVC, so we figured, hey, let's try it for HEVC. And then there's the issue of video orientation. Typically, this is done in WebRTC using the CVO extension, and I guess it could be done in HEVC as well. So that's the extent of the guidance that we have in there. It's not terribly much, but it's trying to get a minimal profile that would allow use of HEVC in WebRTC. Any thoughts?
I think this is useful to do. I'm, trying to figure out if this is within our charter, and I think the answer is probably yes, because RTC Web is closed, but we definitely would want to raise it on the RTC Web list also, just to make sure that I think the list is still open even though the group is closed. So
I think that makes sense. I just thought the HEVC expertise might be more here than.
yeah, I agree. The expertise is here, but that we need the browser side too. I mean, the one quibble I'd have is on the previous thing, you must support receiving it. Is it's possible to build a non-browser WebRTC endpoint that doesn't support receiving video at all. So they must support receiving video at all. So
yeah, we could change that.
Yeah, that's just wordsmithing. Yeah.
So any other comments on things that you think have to be there?
I feel like I haven't. It's been too long since I did any HEVC work, so I'm worried if there's any other parameters that might be needed. But I agree, basically following the general model of AVC of don't use sprops and send everything in band, especially things that can change. Anything that changes when a resolution changes needs to be in band.
Okay,
seems reasonable.
So
you've run this by the people implementing it?
Yeah, well, they haven't gotten to the SDP stuff yet. Hopefully, because they're still working on the packetization, depacketization. But I'm hoping that once they get to that point, they'll take a look at it and see what they think.
Yeah. Does anything need to be said about if you actually support HEVC SVC?
Well, at least right now, because it's hardware only, the hardware support for SVC is really bad.
Okay.
But Yeah, I mean, part of it is just getting a handle on what the chipsets actually do. I mean, if there were some that did it, we should probably put it in to allow them to do it, you know. But right now, we're still sorting through all of the chipsets and what they can do. They're, you know, the problem, Jonathan, has been SVC support has never been high on their list for really any codec.
Sure. Yeah.
It's sad but true, right? So
Yeah, no, that's true. But yeah, I guess the other thing, you know, maybe you'd need to say is if there are actually like, you know, common bugs in hardware codecs that you need to work around. But maybe I don't know if you need
Yeah.
help guidance for that or
there are
just
a lot. Yeah, that's another topic that has come up very frequently, and we have had to pay a lot more attention to that. And one of the really bad ones that we encountered recently with AV1 was that lack of support for spatial referencing in the hardware decoder. So we thought, great, we've got this codec, we can do spatial AVC and the answer, spatial SVC, and the answer is, nah, you can't do that. Now, so well, anyway, what we did is we surfaced it as a parameter in the capabilities where you'd know, hey, my receiver is busted and can't do X. So that may be a lot more of that. I'm sure that more of that will come along.
Yeah, and I'm not positive a IETF document is the best place to track such things, but
right. Yeah, basically with those things, they're not negotiated necessarily. They're kind of transmitted out of band. Hey, I've got a busted decoder in the following respects.
Yeah, and in cases where you can have a fallback to software decoders, it's easier. But the cases here where like with
this will be hardware only, so
HVC.
it's going to be less pleasant. Okay, so I think the next steps is to notify the RTC web list and see if they have any opinions. And maybe if there's any suggestions on changing the text, we welcome them and the list.
Yeah, and personally, I feel like this is good enough for close enough to our charter, so we should be fine. But if anybody, yep, I maybe mentioned that on the RTC website list, saying we're planning to do this in AVC core, but if anybody objects to that, let us know.
Okay. All right. Thank you. So we're going to turn it over to Peter Thatcher.
Test, test, test. Can anyone hear me?
We can.
Okay. If for some reason my network connection fails, which there's a possibility of that, then Bernard will be my backup. All right, next slide. So a review from last time, I presented on how we can packetize S-frame, not S-packet. At the end, I was told to write a draft. So I wrote that draft yesterday, obviously, waited to the last minute. And just to review, it contains the ideas that I presented last time, which are to packetize first with the codec-specific packetizer into one big RTP packet, then encrypt the payload of that using S-frame, then packetize that using the S-frame specific packetization defined in this draft. Which takes the SSRC timestamp and other RTP header values from the first packetization when making the packets in the second packetization. But it takes the payload type for S-frame and puts it in the RTP header as indicating that it's S-frame, and then takes the RTP payload from the first packetization and puts it in the payload for the S-frame specific packetization. And in order to do this, you need to negotiate one S-frame payload type needed. That's right now, I just put myself. I didn't know if Lennox or Ewan wanted to be on there, but they can be if they want to be. I wasn't sure if there should be an introduction like what Ewan wrote previously with nice ASCII art describing the whole process of how S-frame works. I didn't put that in the draft, but we can cut and paste some ASCII art and descriptions if we want. It wasn't decided how the depacketizer would know which packets go with which S frame. So I went ahead and put a media frame ID in the draft, which indicates, the RTP packets for the same media frame ID go together when depacketizing. There were different options for how the depacketizer would know the order of the packets within an S frame and which one's the last. I went ahead and put a frame or a fragment index in the draft, but there are other options. And the question of whether or not we should put all the RTP header extensions in all of the S-frame RTP packets, for example, if there's a mid or a video rotation, should we put that in all the packets? For the benefit of SFUs, for now, I just said all the RTP header extensions go, but we could refine that. And then also the payload type that's embedded in the S-frame specific RTP packet that is copied from the packetization, the codec specific packetization, that I'm putting on all of the packets right now. But if we wanted to, we could try and save a byte, I guess. But maybe an SFU wants to know that byte every time. So there's some possible discussion there. But next slide. The big question is, do we want to adopt this draft? And obviously people are going to want to go look at it first. I just put it on GitHub yesterday. So that's the status. Questions, comments?
One thing I didn't see, one question I know we had is how is the sequence numbers being handled? How does the depacketizer figure out how to describe sequence numbers? Did you handle that, or?
I didn't say anything in the draft about sequence numbers. I was just kind of assuming that it would increment as it went along, just like any normal.
Yeah, no, I mean, I think it's incrementing as it went along, yes, but I mean, I think there was some issue like.
Oh, right. Sorry, yeah. On the depacketization side, when you feed in to the depacketizer the assembled S frames, what sequence number do you use? Yes, I forgot to put that on the slide here, but yes, that is another question. You're right. Anything in the draft at the moment.
Okay. Yeah. Bernard, I see your hand.
Given all the discussion that we have had about SCIP, I would be in favor of having an introduction. And Peter, if you can look at all the comments they had on SCIP, basically being unclear about the whole notion of end-to-end encryption and.
Well, I think the fact that we'll have S frame that we can reference will make things a lot easier. But still,
yeah, that's true. Yes. But I think the whole process may be worth having that in the intro to try to clear that up. Because they also, of course, had lots of questions about how you packetize the encrypted blob. So probably good to have an intro that clears all that up from the beginning.
Sure, I'll pull over an intro from the one Ewan made.
Yeah, I mean, I think this is on the right draft. I think, I feel like, a draft that's a day old is a little early to adopt, but I think this is on the right track.
Yeah, I mean.
So what should the next steps be like?
I don't know. Try to answer some of these questions that are still, like, particularly the ones that you don't have. Particularly
well,
yeah. Go ahead.
I put answers in the draft except for the one that you brought up.
Yeah.
And on the previous presentation, I provided like some options. I said, okay, there's A, there's B.
Yeah.
But I just kind of picked one for the draft at the moment.
I think, the first step would be to get it submitted to the archive and ask for review from the working group.
Okay, I can do that.
Yep. Yeah, I think that's certainly best first step.
So my next steps are add an introduction and submit to the archive and ask for review from the working group. The mailing list, I assume.
Yep. Yes. The next presentation is also you, Peter. presentation is also yours, I think. It says your name on it. Perhaps we lost Peter.
Peter, are you here? You're back. We can't hear you, Peter. Are you muted? Well, maybe I'll read the slide and hopefully Peter can get his audio back. So there was peer-to-peer quick shipped in Chromium as an origin trial in 2019. That was, to be clear, that wasn't IETF standard quick, it was G-Quick at the time, which didn't have the ability to multiplex SRTP, RTP, TCP like we've done with 7983 BIS, but it was a prototype that went out in 2019. It was later evolved into web transport, which became client server only. But it turns out that a bunch of the applications that were envisioned for web transport turned out to be peer-to-peer apps. As an example, people thought that game streaming would be done client server, but in fact, a lot of the implementations out there also are used not just for cloud gaming, but also remoting your game from your console to your mobile device, for example. Similarly, remote desktop isn't just from the cloud to your machine. It could also be trying to get access to your computer at work. So it turned out that the web transport doesn't actually handle a bunch of the use cases that were envisioned, and they need the peer-to-peer stuff too. And so as a result of that, the original discussion about web APIs for peer-to-peer quick is restarting. And so the question, there have been a few open questions about the implementation of the peer-to-peer quick in RTP over quick. And so there's a few things that need to be discussed in the IETF, how quick combines with ICE, registering of an ALPN value, defining how the SDP works, or really I'd say also the authentication model for peer-to-peer quick. And then some of the same real-time congestion control issues that have been discussed for ROC. And there is some overlap here. I think the difference one difference is that peer-to-peer quick was the general thing. It could be used for data, or RTP, it didn't really specify what it could be used for. And the API, by the way, is very, very similar to what's done in web transport, with a few additions that are in the list of documents, basically to establish the peer-to-peer operation. It basically works a lot like DTLS works. It's self-signed certs, and then in the signaling, you verify the fingerprints. So Peter says here, it's important to distinguish between what's in peer-to-peer quick and what ROC does. There may be some similarities, there may be some differences. And I think the next slide talks about some of those. Peter,
Yeah,
are
so
you back?
can you hear me now?
We can
I
hear
hope
you.
so. Yeah, what I meant to say at the bottom was basically like, instead of defining certain things twice, I think we should find things that are the same and define them once. And if it's not something specific to RTP over quick, but rather a more generic P2P quick, we should do the generic way that can be used by both RTP over quick and future other uses of P2P quick. So if I'm still working, I'll go to the next slide. So for example, when you're combining quick and ICE, what we would need to describe are things like demuxing using like the ICE magic cookie, like Bernard just mentioned, using the self-signed certs with signaled fingerprints, turning off quick migration. And then if we have ideas for how to save a round trip when using ICE and quick together, I put some there, but these are things that are an overlap between RTP over quick and potential peer-to-peer
the
quick.
demux is done. That's the 7983 BIS, which is in the RFC editor queue. So good news there. But
oh, good. All right.
Yeah. I mean, the main thing is you have to
I'll
turn
cross that
off.
one off.
The main thing is you can't use the you can't grease the quick bit. You have to actually set the quick bit, because that's the demux point. That's easy enough.
Okay, just took a note.
Peter, are you back?
I'm hearing
Yeah,
Peter. Are you
hope.
here? I have been hearing Peter. Are you hearing Peter, Bernard?
Not right this second, but I was hearing him before.
Okay, yeah.
I guess I should just keep talking
Yeah.
until you know I'm here. I'm still
Right.
here.
Yeah.
I'm still here.
Yeah.
Sorry. Okay, let's move on to the next slide. So the AOPN will probably be something like Q2Q or peer-to-peer quick or something like that.
Yeah.
It would not make sense to have anything more descriptive than that. So the question would be, if potentially someone wanted to implement RTP over quick on top of a peer-to-peer quick web API, would it make sense to have a different AOPN for RTP over quick, or should we just have one AOPN when doing peer-to-peer quick?
Queue management, Bernard first.
Yeah. So my question is, are you thinking, Peter, that peer-to-peer quick would only be a browser thing? Because and what is the meaning of saying, what would be the difference between that and Rock? For example, I guess Rock assumes that the quick is kind of compiled with the RTP stack into one application. Would using the ALPN Q2Q mean that would not be the case? I'm just trying to understand if there's some kind of difference between the two APNs in terms of how they could function.
Well, the way I was thinking it could work is we just define one ALPN to mean we're doing ICE and quick together, and
Okay.
that's peer-to-peer quick. And then RTP over quick would just build on top of that, but still use the same ALPN and not have a separate one, so that you could implement RTP over quick on top of this and not have to worry about AOPN incompatibility.
So you're
But
saying Q2Q is this? It would be used for both native and browser.
yeah, if you wanted a mobile app to talk to a web app, you would use Q2Q, or just keep it the same for native to native, mobile to mobile, whatever. I don't see any reason why you wouldn't just use this AOPN all the time.
Yeah, I mean, the main reason to have an ALPN is to be a demux point for something, and I don't see what this would be usefully a demux point for, because this is all something, by definition, this is all something that has to be fully negotiated before you actually even start the quick connection. So
Question would be, like if you register Q2Q, you could do RTP over quick, but you could do something completely different. And I guess that's to be clarified by the signaling, right? Not by the ALPN.
yeah.
Okay.
Right. We're never going to have a situation where a web app is going to choose the AOPN, so we just need to pick something. But if we want a web app to be able to implement something like RTP over quick, then we can't rely on using the AOPN. But if we don't care about RTP over quick ever being implemented on top of a potential peer-to-peer quick in a web browser, then I guess it doesn't matter. It was just something I wanted to bring up as an overlap between the conversation being started now and RTP over quick.
Mathis?
Yeah, I think it's good that you bring it up, because if we want to do, for example, RTP over quick on top of peer-to-peer, we should, yeah, it should be possible, I guess, but we might want to add that to RTP over quick then too. So not only just define something somewhere else, but it might be important to have that in our document too. So because currently we say that, I think we have RTP mux quick, which says this is for multiplexing RTP and whatever other protocol using the slow ID. And if you use RTP max quick APN, then we expect this wire format. And if we define something else for peer-to-peer, then that may be important in our document too.
Okay, well, I think I'll just keep going here. Next slide.
James, did you have your hand up?
Yeah, I did. I don't think that the ALPN is the right place to be putting the signaling of this is a peer-to-peer thing and not a usual server-client interaction. This really needs to belong elsewhere, but I also recognize that trying to extend Quick itself to support that would be kind of difficult because you're conflating both the peer-to-peer aspect and the RTP in something that really should only be handling one of those.
Yeah, I feel like there's a way in which the ALPN semantic is designed for the HTTP use case, and I'm not sure it semantically matches what we're trying to do here very well. So we kind of just have to put something there and then do the things we actually need at some other level.
I mean, it's either that or make it a part of the web API to choose the ALPN, but
that seems fraught.
I don't know. That seems right.
Yeah.
Well, anyway, in the interest of time, I think I'll skip to the next slide. Yeah. So I just wanted to. This would not be part of the web API because we do not want to have more SDP in web API. But if you wanted to use SDP to signal peer-to-peer quick, I think that it would look something like this, where it looks almost exactly like when doing ICE and DTLS together, except that the string for what it is, I forgot what that string is called, is different. So it's UDP/quick. It's all the same attributes for ICE and the role and the fingerprint. Next slide. And then I even thought, okay, if you wanted to do it together, then with RTP, you could just stick in RTP parameters there. And so I don't actually know what SDP you've come up with for RTP over quick, if you have any, sorry. But it didn't seem to me that it would overlap much. I mean, sorry, it wouldn't conflict much. But we could, if we wanted, separate the definition of the pieces that are for peer-to-peer quick and those that are not, if we care to. For the web API, like I said, we don't need to define the SDP at all. It's just one of those things people always like to have. They like to have some SDP.
Peter,
next slide.
This is Spence.
Yeah.
So I was working on a draft on SDP for what is now ROC. I stopped doing that because the functionality that we had defined for ROC so far was not, we had not defined enough of the functionality, and we did not have consensus for enough of the functionality to justify trying to maintain that in parallel. So this is definitely something I'll be interested in talking about fairly soon, because honestly I've been helping with RTP over quick and waiting for us to do the the ICE interaction thing before I move forward on that.
Okay. Well, I think
don't worry about it conflicting now, but let's worry about making sure it doesn't conflict in the future.
Okay. Well,
yeah, and
I
you can
have two
take
thoughts. One of them is that.
Go
ahead.
I was going to say you can take a look at Spencer's expired draft, even just for you can see what his ideas were, but unlike the UDP/quick ideas, so it's just based more or less matches what you have here. So.
Well, it's almost exactly the same as what WebRTC does with ICE, DTLS, and RTP together.
Yeah.
It just happens that you can also send data by itself without having SCTP in the mix, kind of. So the only thought I would have there is if we get to the point where we're going to define these, it might make sense to define in two separate drafts, one for the peer-to-peer quick things, just ICE and quick by itself, and then a separate one for RTP being added on top of that, so that people that are doing just peer-to-peer quick wouldn't need the RTP parts. But I guess it could be two sections in one draft. I don't know. I just wanted to make everyone aware that it might be useful to separate out the non-RTP parts of quick plus ICE.
Right. I would point out that this similar kind of question has now come up in the rechartering of the WISH working group, where people have raised, there's the whole RTC data channel, the WebRTC data channel signaling, and people have wondered, how do I signal something being sent over the data channel? For example, if media is being sent over the data channel, because today the WebRTC data channel is just generic, like what Peter had for the UDP quick, right? It doesn't say what's being sent over it. But in which the need has come up for maybe trying to specify that more, like extending it like what he's describing here. So I think this problem has come up. This RTP might not be the only media that gets sent over this channel. Like, for example, in WebRTC data channel, CMAF gets sent over the data channel very commonly. Anyway, so I think there's something in common with some of the issues discussed in WISH here.
Peter, we do not hear you at this point. You're muted.
The other piece of overlap is the real-time congestion control thing. And I think we should try and solve this for everybody, not just RTP. And so basically adopting or requiring an extension like the one I linked here. And then somebody needs to port something like GoogCC to an implementation of Quick and see how well it works. It's on my to-do list to keep trying that, but I haven't done it yet. So, but I think that effort should be done in a way that is not just for RTP. Or I should call it rock now, right? Not just for rock. That's it. That's my last slide.
Bernard, are you in queue or are you lingering?
Out of the queue.
Answer?
Yeah. Meredith and Jorg and I have not cut a new version of the rock draft since 116. We expect to do that before 117. And if we weren't busy closing PRs the last couple of weeks, we would have probably done it before this meeting. But just possibly to encourage people to think about what they need to be reviewing. One of the big things that we had in the rock draft was ideas about what should be going on, basically what Quick should be doing for real-time media. And so I've been trying to be clear about that, and to make sure that we were not over specifying that, because there's, from my perspective, there's still a lot of unknowns about real-time congestion control and for media and interaction with that with other kinds of traffic that are sharing the same network paths or quick connections or whatever. I was not following RMCAT as much after Miria took that. She joined the ISG, and she got that working group because she knew more about it than I did. I'd been the AD for it, but she'd been the chair. So I don't know everything that I would like to know about the RMCAT algorithms, but my impression was that they had done a lot more work on making sure you were not congesting than looking at how you were interacting with other congestion controllers, especially for congestion controllers that were not, that congestion controllers that were not being used for real-time traffic. So I'm sorry, I'm not clear on this. I think I'm more clear than what's coming out of my mouth, but I think that what to do is a really good idea. I think it could be consistent with the rock draft, and if it's not consistent with the rock draft, we should probably have a conversation about why that would be different. So I would encourage you, I would encourage you to continue thinking about that. I would encourage myself and the other rock folks who've been typing in the draft. I would encourage us to have a conversation more, have conversations about this. But I think that specifying this once for real time that is not restricted to RTP is a good plan. Thank you for raising that.
So yeah, I guess my main question is, I think, where do you see this work actually being done? Because I think this is, it's important for AVT Core to be aware of this for the ROC, but I don't think this itself is in scope for AVT Core. So do you see this in Quick Proper or some new group or W3C or what? Peter, I'm hearing background noise, but not you.
Oh, sorry. That maybe did you mean peer-to-peer quick in general?
Yeah, peer-to-peer quick in general, yeah.
I don't know where the right place it should happen is, if we should make a new working group or what, kind of like we did with web transport. I don't know. That's a good question.
So I apologize for jumping in. I was aiming to click the raise hand thing and managed to close my window for Meet Echo. So I missed about the last 15 seconds of what Peter was saying, or I missed about 15 seconds of what Peter was saying.
I was just saying that it was a good question, that where we should do work for peer-to-peer quick. If it's not RTP specific, does that no longer fit in AVT Core? And if not, then where should it go? And I don't know the answer to that. It's a good question. For web transport, we made a new web trans working group, and maybe we need one for peer-to-peer quick. I don't know.
So I am not current in the past week about what the charter for the congestion control working group that's in the process of chartering. I'm not quite sure what their charter says right now. I don't know if that might be a place to have this conversation.
The conversation about the congestion control, probably. The conversation about peer-to-peer quick in general, I don't think so.
Okay, yeah.
Yeah, and maybe it should be, my first thought, would be take it to the quick group itself and see what they think, if it's small enough that it can be done in quick itself or whether it would need a new working group.
Somewhat amusingly, I think Quick would have, the ADs, the transport ADs would be the people who would know this. But my understanding is that the quick working group would probably have to recharter to take that on. But Peter has raised a good question, and all we have to do now is figure out how to answer it.
Mhm. Yeah, and obviously the web API parts of it are in the scope of W3C, right?
Right. Or would be. We still need to find the right home for that too. But you were saying the congestion control part of this might be done somewhere else?
There's a new congestion control working group.
Oh, there is?
Which, yeah, I'm not sure how much this is what they're initially looking at versus
for real time.
And
not for real time
there,
specifically, but but I don't think real time is out of their scope.
right. So what I was trying to say was, I don't know. They've been in the process of chartering since before 116, and the last time I looked, which has been within the last week, they were still in the process of chartering. So I don't actually know what's in scope for them, because that's, and until the charter's approved, I'm not sure who knows. But so I'm not saying that that's a good place to do that. I'm saying that it's a good place to consider whether it's a charter for them, or whether they think it should be a charter for them. That was all.
The name of the working group?
Conveniently, it's the Congestion Control Working Group. It's one of the ones that's not being renamed after after a couple of hours. I'm not sure what else you could call it, but that's what it says in the data tracker.
Yeah. I think all the clever names turned out to be offensive, mean something offensive in some language, so they gave up and called it CCWG. All right, yeah, so I think this is important work. The ROC people should keep an eye on it, but I don't think the core of the work is in scope here. Obviously pieces are and should influence ROC, but I don't think we would need a draft beyond ROC. Just that this draft needs to keep in scope, and the authors of ROC need to keep an eye on this and hopefully stay in sync with it and contribute to its requirements wherever that happens. That's all right to everybody? All right, in that case, we are done. Thank you, everybody.
Thank you, everybody. IETF.
Yep, see you.
So Bernard and Jonathan,
Yeah.
I captured as much as I could in the notes, and I'm still making updates. So don't cut and paste them into the data tracker yet.
All right.
Okay.
But
Yes,
thank you.
I'll be finished in probably 30 minutes or something.
Okay, thank you so much.
Stefan also had some notes. I don't know if he forwarded them to you, Spencer, but I will forward them.
Yeah, I haven't been able to confirm or deny that yet, because he was.
I think he sent. Oh no, he did send to you. Okay, yeah, he sent to you, Bill.
I'm forwarding to you, Spencer.
Cool.
At Dawkins at Global 10 Cent. I think that's your email.
Oh God, no. Spencer Dawkins at spencer.dawkins.ietf@gmail.com.
Okay.
Yeah.
Okay, yeah, it's an old email. He had an old email address for you, I guess. All right.
Cool. But thank you.
Yep. All right. Thank you.
Bye.
Bye-bye.
Are you off the phone?
Yes, I was too blasted to take my stupid headphones off. I'm trying to finish something while I can still remember what was going on,
That's fine.
because I was also taking notes. Did I tell you that?
Say if you
Huh?
That's fine. I just didn't know.
Yeah. This is when I got silent. A reasonable question would be, yeah.